Hello everyone, this is Sarvachan Verma, and currently I am working as assistant professor in at AKGEC Engineering College in IT department. And in last video lecture series I have discussed three types of agents. First one is simple reflex, then model, and finally goal based agent. In now continuity to discussing utility based agent. If we are talking about utility based agent, so basically these agents are similar to goal based agent but provide an extra components of utility measurements, which makes them different by providing a measures of success at a given state. Means utility based act as a based not only goal but also the best way to achieve the goal. It means they find the best way to achieve the goal based on applying utility based model, utility based knowledge. Now utility based agent is useful when there are multiple possible alternatives, as an agent has to choose in order to perform the best action. Suppose we are moving through straight forward to the roads, and after that we will see here we have two way. Suppose I want to go from Ghaziabad to Delhi, and for moving towards Delhi we find two routes. They are going to, both routes move towards Delhi, but some is take large kilometer, maximum kilometers, and the second ones compared to the 1 or 2 kilometer less than. And in that scenario utility based agents apply the utility based on heuristic approach. What is the meaning of heuristic approach? Because every node has knowledge of the goal. So you will see here, through these situations you can find the best routed on every node. This is the example of utility based agent. Okay, now we will see here, this is the model, this is the utility. It perceives the environment through the sensors and perform what the world is like now, what it will be like if I do action A. Finally take the some knowledge from the predefined model, and finally it perform the actions according to the actuators. Suppose this is the best example I want to discuss because this is very good for you. Suppose I am going to from this direction, this is the way, this is my goal state, this is my goal state, this is my goal state, and we have two way. This is the first way and second way, and this way move to this and this may move to this. Okay, we will see here, this take, suppose from this node it will take 10 kilometer and this will take 20 kilometer. Okay, but you will see here definitely I will choose this route, but every inside whatever roads are required, they have good knowledge about your goal. You will see here I will take this, but inside this node have some jam here. Okay, at that position we have no knowledge about the whole area which is moved from this location to this location. In that situation utilities are used. Okay, because every node contain the locations to the next node, sorry, ये contain the informations to the next node. In that situation you will see here they will take this road. Okay, because of every node has a knowledge of next node. Okay, so this is the utility based agents. Last one is learning based agent. If we are talking about learning based agent, a learning agent in AI is the type of agent which can learn from its past experience, or it has learning capabilities. Basically, it start to act with basic knowledge and then able to act and adapt automatically through learning. Okay. Now, so this is total about the learning agents, goal agents, model based agents, simple reflex agents. Now I am going to discuss problem solving. This is a very good example. You will see here vacuum cleaner world. Now I am already discussed agent type, which type of agent you want to go, you want to take according to your problem domain. Now in this picture you will see here, in vacuum cleaner world problem, we have two locations, left and right, and in both locations there is a may or may not be dirt is present or not. Okay, you will see here, if we are designing, if we are provide the solution of this vacuum world, so you will see here we have, for these two locations we have 8 locations are there. First is vacuum agent available in left side or maybe in right side. In bad situation, both locations contain dirt. Similarly, this is the second positions, third location, fourth location, fifth, sixth, seventh and eighth. So inside this figure you will see here we have 8 locations of this particular vacuum world problem. Okay, whether one state contain dirt and another is clean. Similarly, first is clean and vacuum is another direction. Okay, if we talking about this location, you will see here, if this vacuum world observe the environment, okay, through sensor, if they find this location is dirt, then move to the left, right direction, right location. Okay, similarly, so this is the particular scenario. Now, the vacuum world problem can be formulated as a problem as follow. State. First, we have, if we are going to design a agent, so we have must concentrate on these parameters whatever I discuss. First one is state. The state is determined by both the agent location and the dirt location. Okay, we can find the state where our agent or by the dirt location. Second thing, what is the status of agent? Agent is in one of the two locations. First one is, it may be in left part and it may be right part. Third one, each of which might or might not contain dirt. It is observable environment by the sensors. Okay, now, so you will see here there are 2 into 2 की power 2 8 possible world state. A larger environment with n locations has n into 2 की power n states. We can find for 2 locations, so we have already find there are possible 8 states are there, because the formula is 2 this is the formula, 2 into 2 की power. If we have locations n, then we can find easily by this. Okay, now what is the initial state? A initial state can be locations 1 and location 2. There is a no issue. Any state can be designated as a initial state. Action. What actions performed by the actuators? So it is a simple environment. each state has just 3 actions: first, left and right and suck. So there is a 3 actions performed by the particular agent. Either it move to left for B location, either they move to right for A location and shuck. In large environment they move up and down according to the situation. So we can design the coding for actuators also for up and down also. Third one is a transition model. The action have their expected effects except that moving left in the leftmost square, moving right in the rightmost square and shucking in a clean square have no effect. Okay, the complete state space is shown in the figure like this. This is the complete space. Now, goal state. What is the goal state in the vacuum world environment? To check whether all the squares are clean or not. This is our goal state. Path cost, because of each step cost 1, so that the path cost is the number of steps, number of moving to clean up the both locations. Okay, so this is the solution, this is the procedures, this is the process to simulate our problem in AI. Whatever type you got the problem, first you have to find out the number of locations, initial state, goal state, what are the transitions are applicable, what are the different actions performed by the actuators. So first you have simulate this type of problem like by all these parameters. Okay, and this is again the second problem. This is the typically a instance of 8 puzzle problem. You will see here, this is the 9 blocks and this is my initial state and this is the goal state. Okay, we are going to we are moving from this location to this location. So what is the state? So in this diagram, a state description specifies the location of the 8 tiles and the blank is one of the 9 square. Okay, this is the state. What is the initial state? Any state can be designed as an initial state, not that any given goal can be reached from exactly half of the possible initial state. What is the actions? The simplest formulation define the actions as movement of the blank space left, right, up and down. Different subsets of these are possible depending on where is blank is. Fourth one is a transition model. To give a states and actions, this return the resulting state. For example, if we applying left to the start state, the resulting state has the 5 and the blank switch. If we talking about goal state, so this check whether the state match the goal configuration. So the goal configuration are possible and it may be changed according. Path cost is 1 because we are moving left, right and up and down. Similarly, this is the third problem I will discuss, route finding problem. So if we're talking about the applications of route finding, the applications of route finding are not limited to the traffic routes. This is the very in n number of applications are there in route finding. Okay, you will see here in websites, router always route the particular packets to a destination. In car system that provide driving directions. Routing video stream in computer network. This is again a applications of route finding problem. Military operations planning. This is again applications of route finding problem. Airline travel planning system. and number of applications are there. If we talking about, if we are going to formulate the root finding problem in the form of these parameters, these attributes, we will see here first one is state. So each state obviously include a location and the current time. Furthermore, because the cost of an action may depends on previous segments, their fare basis and their status as domestic or international, the state must record extra information about this historical place or not. So these are the states. Initial state, this is specified by the user. This is not a, we cannot define the initial state because of if a customer going take the flight from Delhi, so that is the Delhi is the initial state of that particular agent. Action. Take any flight from the current location in any seat class, leaving after the current time, leaving enough time for within airport transfer if needed. Okay, these are the some actions. Take the flight, get the current location, take the seats class, leaving the current time, we will note when the particular agent will remove. Fourth one is a transition model. The state resulting from taking a flight will have the flight destination as the current location and the flight arrival time as the current time. Next one is goal test, as we at the final destination specified by the user. So in this situation, root finding problem, initial state and goal state set by the particular user. Path cost, this is depends on waiting time, flight time, customer. There is a lot of parameters to find out the particular path cost. So this is the about the problem solving. So basically in previous video I have discussed 3 agent type. In that video I will discuss how we can solve a particular problem. Okay, second one is problem solving. N number of problems, there is a lot of problems are there, like vacuum word problem, like a taxi driver problem. So to formulate a particular problem, we always focus on 5 to 7 parameters like states, initial states, then actions, transition model, goal state and path cost. This is total about the problem statement. Okay, thank you so much.